What are the options to increase the data rate to go to 400G and beyond? So there's basically three vectors in which you can increase the speed. So you can, on one hand, you can increase the symbol rate by, for example, going from a 32 gigabaud towards a 64 gigabaud. You can increase the constellation size. There's a couple of example constellations depicted on the right-hand side. So this increases the bits you transmit for each symbol. By going, for example, from a QPSK to 8 QAM to 16 QAM to a 64 QAM, you can increase the final data rate. And you can also add additional carriers to your signal, so to generate so-called super channels, which are having one origin and destination that they're being transmitted, either by using, for example, a Nyquist wavelength division multiplexing scheme or a multiband OFDM type of scheme or others, to generate very dense optical spectra with high spectral efficiency. So to give a little bit, a few numbers to how to achieve 400G, there's a lot of different options. This is a discussion that's also going in within the optical internetworking forum. As a reference, take a current 100G signal using a 32 gigabaud QPSK, which requires a bandwidth of about 50 gigahertz and achieves a spectral efficiency of about 2 bit per second per hertz. The required OSNR is about 12.5 dB, and that means you can reach a transmission of about 200 kilometers. So scaling that up to 400G, for example, could be done by adding a second carrier and moving from a QPSK to 16 QAM. You already see here that this also increases the channel occupancy, so you cannot fit that into a 50 gigahertz channel anymore. Also, the spectral efficiency is not fourfold, but it's increasing to about 5.3 bit per second per hertz. And you also see that the required OSNR has increased, which means that the maximum reach that you can transmit this 400G signal has decreased. Another option would be to go in a single channel system, keeping the 16 QAM modulation format and increasing the symbol rate to, for example, 64 gigabaud. On the downside, however, you also need twice as much OSNR at the receive side, so you have the transmission distance that you can go with such an implementation. And there's a couple of others that are being discussed, which also can be used to generate 400G aggregate data rate. And as you can see, this is 2 carriers or even 4 carriers, requiring even more channel bandwidth. So for example, 100 or 150 gigahertz, you decrease in spectral efficiency. But then on the other hand, for example, on the right-hand side, the 4 carrier QPSK system can reach the same transmission distance again. So you already see there's a big trade-off between the spectral efficiency, the implementation penalty, and the reaches that can be achieved. So it's a matter of the applications, which one suits the best in this discussion.